Now there are two special limits that you just need to memorize. We can go through the process of learning how we got to these, but we're not going to do that at this particular time. I just want you to memorize that these two limits exist. Anytime that you see the sign of something over that same something. So since this is x and this is x, and it's x approaching 0, we can conclude that the limit is 1. If this were y and this were y and it was y going to 0, the limit would still be 1. If this were 7x and this were 7x and x is going to 0, we could again conclude that it's the number 1. So as long as the argument here is the same as this down here, the limit's 1. By the same token over here, if we have 1 minus the cosine of something over that same something, the limit is 0. These are just two trig limits you memorize because we will use them from time to time. Now very seldom will you see these written out just like they are. For example, this limit, when you look at it, doesn't have anything to do with sine x over x or cosine or 1 minus cosine x over x. But if you try to put in a 0, you get the tangent at 0 is 0, x is 0, so we get indeterminate form. So since we got indeterminate form, we know we need to do something. Well, what can we do? If we go back and if we recall that, how could we write the tan? We could write the tangent as the sine x over the cosine of x all over x. Well, that could be simplified. The limit as x approaches 0 of the sine of x over the cosine of x times x. Now how did I get there? I took the denominator here and I flipped it over and multiplied it. So I made it, instead of dividing by x, it's multiplying by 1 over x. Well, how does that help the situation here? Let's write it a little differently. We've got the limit as x approaches 0 of sine x over x times 1 over cosine x. Now, does what I just wrote here in green agree or mean the same thing as what I wrote up here in red? If I multiply these two green things together, I get back to the red. Well, now what is sine x over x? Remember, that's one of the special limits we just talked about, and we know that the value of that part is just 1. So now we can simplify this to 1 times the limit as x approaches 0 of 1 over the cosine of x. Well, we've got a number in the numerator, so we should be able to evaluate this. 1 over the cosine of 0. The cosine at 0 is 1. You need to look that up. You need to be memorizing it or using your hand trig to determine what it is. And 1 over 1 is the number 1. So we've concluded from all of that that this limit is actually equal to the number 1. Now let's look at another example. What about this? We've got the limit as x approaches 0 of the sine of 3x over x. If we put in 0, we get 0 over 0. So what can we do here? Well, if we look at it, these two things, the argument and the denominator, are almost the same thing. Remember, we said if we had the sine of 3x over 3x, then we could conclude that this limit was the number 1. Well, how can we introduce a 3 right here to make that happen? Well, let's multiply this by something. But we can only multiply it by the number 1, so let's multiply it by a special name for the number 1 called 3 over 3. Now, where did I get the 3 from? How did I conclude to use 3? Well, because I've got a 3 up here, I'll use 3 over 3. If it had been the sine of 7x, I would use 7 over 7. If it had been 5x, 5 over 5. So let's see what happens now. We've got the limit as x approaches 0. I'm going to pull the 3, this 3 I'm going to move out in front, times the sine of 3x over 3x. because if I multiply the 3 in the denominator by x, I get 3x. Well, this part right here is our special limit, isn't it? So we can utilize that part and say then this becomes the limit as x approaches 0 of 3 times the number 1. Well, there's no fraction, so we know we can evaluate this now. There's no x to put in. So then the limit has to be the number 3. Now after you've done a couple of these, maybe you can start realizing that, well, what would the limit as x approaches 0 of the sine of 5x over x be? If you go through the math like we did here, you should find out that that limit is 5. I invite you to try that and be sure that you can get through the math to do that. And so you can come to a conclusion that whatever the number is here, if it's 5x over x, then as long as it's a sine, as long as it's going to 0, you can reach the same answer. It's going to be 5. If it had been a -7, the answer would be -7.